All right, everybody, we are going to be going over free response question number 15. Like I said on the website, you should be doing these problems beforehand and then just using these videos to double check your work and making sure you're putting a full, complete response and getting full credit on each section of the question. All right, so let's read through number 4. The chemicals and clay used to make pottery can differ depending on the geographical region where the clay originated. Sometimes archaeologists use a chemical analysis of clay to help identify where a piece of pottery originated. Such an analyst measures the amount of a chemical in the clay as a percent of the total weight of the piece of pottery. The box plots below summarize and analyze the 3 different chemicals X, Y, and Z on pieces of pottery that originated from one of the 3 sites, 1, 2, or 3. So part A says for chemical Z, describe how the percents found in the pieces of pottery are similar and how they differ from the 3 different sites. So if we look at our graph, what we're dealing with here, kind of like a complex box plot, because we have 2 variables that we're looking at, the different sites and then also the chemicals, and we're seeing how they measure against the percentage of total weight. As you can see here, we have a key that's going to help us. Let me circle that. So we have a key right here, and you can see the different shading. The first site is site 1, and then another one site 2, another one site 3. Also notice how the box plot is now vertical. Okay, it doesn't really change anything except it's just vertical now. So, for example, if I was looking at this box plot right here, then this would be my minimum value. This line would be Q1. That'd be my median, Q3, then max. So it's the same thing. The higher values are going to be, we would usually look to that on the right side of the box plot, and then lower values would be on the lower side. So for part A, we're trying to see how chemical Z is different and similar. So if we look at chemical Z, it's going to be this box plot right here. It's going to be the one on the right for each of the 3 sites. So when you're, again, comparing different box plots like this, you want to think about SOCs, the different components of that. So one of the first things you want to look at is where the center is at. And if, as you can see, we have very similar, that was a bad draw right there. We have similar medians. They're all around 7. So that means that they have similar centers or similar medians at approximately 7. All right, since it's not directly on one of the lines that's given to us, we can't say this for sure 7, but it looks like it's pretty close to 7, if not exactly 7. So we're going to say approximately 7. So that's something that they have similar to each other. So something else they have similar to each other, you could have also talked about the shape. And then something that is different is that they do not have the same variability. If we look at site number 2, that's going to have the lowest variability. Site number 3 is going to have the highest variability. It's going to be the most spread out. And then site 1 is in between those 2 different values. So let's look at my response that I put down for part A. As I said, for chemical Z, all the sites had the same median of approximately 7%. However, the variability differed between the 3 sites. Site 2 had the lowest variability with the interquartile range at approximately 1% and a regular range of 2%. Site 3 had the highest variability with the interquartile range around 4% and a regular range around 8%, and site 1 was in between those 2 with an interquartile range of 4% and a regular range of 6%. If you want to, you could also talk about how the shapes are similar with each other. Okay, you should have just had one of those two things down for how they're similar. Talk about the center of the shape, and then if you include both, that would be even better. And then they're different with the variability. Okay, you see there's no outliers, so that's something we don't have to talk about. If there's no outliers given to you in the problem, they don't ask you a specific question about it, then you don't really need to talk about that. So if you look at my response, again, think about how I include context in this sentence, all right, or in this response. In that first sentence, for chemical Z, all the sites have the same medium, boom, right there I have that context. So for chemical Z and all the sites, if you just said they all have the same median, that's not including context. That's what a lot of people were messing up or missing in their responses from last class. So make sure you're including that context in your sentence. So if somebody was just reading your written response, they know what you were talking about, not just random medians or interquartile ranges or variability. The same thing, I'm including the site numbers in my second sentence, so I have context in every single sentence, and it's also concise. So that's the things they want to make sure that you have in your response. Talk about one thing that's similar, talk about another thing that's different, and then make sure you have context, nice concise sentences. Let's look on to part B now. So it said, consider a piece of pottery known to be originated at one of the three sites, but the actual site is not known. So part 1 says, suppose the analyst of the clay reveals the sum of the percents of the three chemicals is 20.5%. Based on the box plots, which site, 1, 2, or 3, is the most likely site to where the pieces of pottery originated? So they're saying that we have this piece of pottery, you add up all the chemicals together, is 20.5. So we want to see which site, if we add up our best guesses to where the average is, or the center is, for all those sites, which one's going to be closest to the 20.5. So if you added up all the sums of the medians, we want to add up the medians because the center is like our best guess of where the average or center is. So you want to make sure that you add up the medians on this. So if you added up the medians for site 1, it was a lot higher. Scroll down, see what it came out to. Site 1 was 27%, so that's higher. Site 2 came out to 16.5%, and then site number 3 came out to, I believe it was approximately 20%, which is really close to 20.5. Again, it's not an issue that's not exactly 20.5, because remember, anytime we're doing real life statistics, there's going to be natural variability. Okay? Like, let's say my average weight really is, let's say 155 pounds, but if I weigh myself every day, there's going to be random days where I'm a little bit below that or a little bit above that. Okay? So that natural variability, if we're only off by 0.5, that shows us that site 3 is a really good fit. So then we go on. Just listen and read through my response that I put down. Again, try to think about how I'm including context, then also using actual summary stats to back up my claim. That's another thing that you want to do, is if you have these summary stats, which is easy to get from these box plots, you want to make sure you use that to back up your claim. So site number 3 is the most likely site, because when you add up the medians of the three chemicals at that site, you get 20%. It's not that clear right there, so you want to make sure you're writing clear, unlike what I did there, so your grader, either me or the person on your AP test, can read it. But 6% plus 7% plus 7%. So you're showing, I'm doing that because I'm showing whoever's looking at my paper where I get that 20% from, which is close to the sum of the analyzed sample, 20.5%. The sum from the other two sites were not as close, with site 1 being 27% and site 2 being 16.5%. So again, nice, concise, clear response. You want to try to be as thorough as you can in as few words as possible. using context, and then also using numbers from the data that's given to you or the summary graphs that are given to you to back up your claim. Let's go to the last part, part 2. Suppose only one chemical would be analyzed, the piece of pottery. Which chemical would be most useful in identifying the site where the piece of pottery originated? Let me erase all this used from the first part. So as we're thinking about this, we really want to look for the chemical that is the most different, right? Because if the chemical is the same at all 3 sites, and we're only looking at that chemical, it's not going to help us determine which site it came from. But if there's a chemical that's different between all the 3 sites, then if we know it's, for example, it's high at one site, low at another site, and medium, that's going to help us determine which site the pottery came from. So if we look at chemical X right here, you can see that they're all very close together. They have low variability, and their medians are all within like 1.75 of each other. So they're very close together. So that's probably not going to be a good indicator of what site it came from, because especially even when we look at sites 2 and 3, they have the same median. So if I had a piece of clay sample that was 6, I wouldn't know if it's coming from site 2 or site 3. So let's look on chemical Y. Chemical Y, on the other hand, site 1 is really high, and then site 2 is very low, and then site 3 is in the middle. So we have a lot of variability there, which means that it's going to be easier to determine which site that piece of pottery came from if we're looking at chemical Y. But let's keep on looking at the last one just to double check to make sure Z's not a better choice. If we look at Z, they have exactly the same median, just like we talked about in part A. So that's not going to be good because they're probably, no matter where it comes from, they're all probably going to have the same sample, or the same median, or same measurement. So if we get a sample that's 7, that's not going to help us determine which side it came from because they all have medians at 7. So chemical Y was the best choice. And again, let's read through the response. Chemical Y, because the percentage varies the most between the 3 sites, which would make it the easiest chemical to tell which site the pottery originated from. Okay, I see one sentence really clear about including the context and also using that statistical terms. The varies, talking about variability. You want to try and include that statistics terminology in your response as well. So you kind of use this to help, again, just refine how you're writing these responses. We're spending 2 days reviewing this because there is so much. You're going to see these questions, probably be at least one of them on the free response question on your AP test. And it's really important that you know exactly what they're looking for and you're getting practice writing these good responses. So again, just really make sure that you're trying to include your context. Almost everybody did not include that on their work from Monday. So just double check that, make any corrections before moving on to the next free response question.